In the last presentation, we saw the introduction of field effect transistors, and the first field effect transistor we have to study is junction field effect transistor, popularly known as JFET, where JFET is the abbreviated form of junction field effect transistor. There are two types of JFET. The first one is N-channel JFET and the second one is P-channel JFET. In this lecture, we will see the construction and working of N-channel JFET. If you remember the BJT lectures, we used N, P and BJT to understand the concepts and problems. Now while discussing JFET, we will use N-channel JFET. You can see the construction of N-channel JFET on your screen, and the major part of JFET structure is N-type material. You can see the major part of the structure is N-type material, and it is forming a channel between two embedded P-type materials. We have two P-type materials, and this N-type material is forming a channel between these two P-type materials, and because of this reason we call this structure N-channel JFET, because N-type material is forming a channel between two P-type materials. And when you see the construction of P-channel JFET, you will find P-type material is forming channel between two N-type materials. You can see 4 ohmic contacts in this structure. This is the first ohmic contact, and this terminal is the drain terminal. The drain terminal represented by capital D. The second ohmic contact is this one, and the terminal here is the source terminal represented by capital S. The third and fourth ohmic contacts are connected together, and one common terminal is taken out, which is called as gate. This is the gate terminal represented by capital G. JFET is a 3-terminal device. Like BJT, JFET is also a 3-terminal device, and when you see the physical structure of JFET, you will find it is like BJT. When you see the physical JFET, you will find it is having 3 legs like BJT, and the construction is same as BJT. In case of junction field effect transistors, there are 2 PN junctions. There are 2 PN junctions. The first PN junction is formed between this P-type material and the N-type material, and the second PN junction is formed between this P-type material and the N-type material. And because of this we have two depletion regions. 2 depletion regions are formed at 2 PN junctions. The pink portion in the construction is the depletion region or depletion layer, and we already know depletion region is depleted of free charge carriers. There are no free charge carriers in the depletion region, so it will not help us in conduction. And if you increase the width of depletion region, like this, then width of N channel will reduce, and because of this there will be obstruction in the flow of electrons. When you connect drain and source terminals to a potential difference, then because of this potential difference the free electrons in the N channel will be drifted like this, and the conventional current ID will flow like this. But if you increase the width of depletion region, the flow of electrons will be obstructed, and we can control the width of depletion region using the gate terminal. So we can control the flow of electrons by using the gate terminal. The potential difference between the gate terminal and the source terminal will control the width of depletion region, and this potential difference VGS will now control the output current ID. So we call this device voltage controlled device. BJT is a current controlled device, and if we talk about working of BJT and working of JFET, then working of JFET is very easy to understand. The working of BJT is little bit complicated as compared to the working of JFET, and from this explanation you now have some idea about the working of JFET. But before moving to the complete explanation, I will first try to explain one simple analogy. To understand the working of JFET, we will try to understand the working of spigot. You can see spigot on your screen. It is also called as tap. This knob here is called as valve knob. The water is coming out of spigot from the overhead tank. We have the overhead tank, and the water from overhead tank is coming out of spigot, and here we have the drain. This is the drain, or you can say the sink. Now let us try to compare the working of JFET with the working of spigot. Water is coming out of spigot because of potential difference. The potential of this stored water is the reason for the water coming out of spigot. So we can say that the cause of water flow, in case of spigot is same as the applied voltage between the drain and source. The applied voltage between drain and source, because when you apply voltage between drain and source, the electron in the n channel will drift, and water is same as electron in the n channel. The next comparison is between the valve knob and the gate. Here the valve knob is controlling the water coming out of spigot, and here the gate is controlling the movement of electron in the n channel. So we can say that valve knob is same as the gate in JFET. The next comparison is between the sink and the drain. The sink in this case is same as the drain in case of JFET. You can see water is going in the sink, and here electron is going towards the drain, so their working is similar. The next comparison is between the source in case of JFET and the source of water in case of spigot. The source of water is definitely the tank, the overhead tank, but if you see only this portion, then you will find the source of water. This is water. The source of water is nothing but the spigot. So source of water is spigot, and this water is going to the sink, which is working like drain. So spigot is working like source in case of JFET. So I hope you now understand this simple analogy, and if you have any doubt, you may ask in the comment section. In the next presentation, we will discuss working of JFET when VGS is equal to 0 and the potential difference between source and drain is positive. VDS is greater than 0 volts and VGS is equal to 0 volts. So this is all. See you in the next one.